In today's video lecture, we will solve 2 to 3 problems, okay, which is the end of this module 1. So problem first, given a beam of plane waves in water, so underline the word water first, because there are different values for air and water, to contain 100 watts of acoustic power distributed uniformly over a circular cross section of 40 centimeter diameter. The frequency of the waves is 24 kilohertz. Determine. There are 6 things you need to find out. The first thing is the intensity of the beam in watts per centimeter square, the sound pressure amplitude, the acoustic particle velocity amplitude, the acoustic particle displacement amplitude, the effective or the root mean square pressure, and the sound pressure level, that is SPL. RE is reference 1 microbar. So all these things we need to find out for this given case. So first job is the intensity of the beam. Okay, so we have seen many formulas till now. Okay, so we need to first get the value of intensity I. So the formula what I taught you, formula will be I is equal to power, because you have been given power, divided by area. Normal formula what we use. Now how much power is given to you? Just check it. It's 100 watts power. So P is 100 watts. And how much is area? Now for the area they are given for circular cross section of 40 centimeter diameter. So if the dia is 40 centimeter, obviously radius should be 20 centimeter. And I want the value in watts per centimeter square, so I don't have to break my head to convert it into meters. Okay? So directly we can write pi r square and substitute the value of r to be 20 centimeter. Understood? And as this is a circular cross section, so you need to use the r, so area should be pi r square. Fine. So what will I write? I'll write 100 divided by 3.14 into 20 bracket square. So if you simplify this with the calci, okay, I checked all the answers and the answer will be in the range, okay, of 0.07961 watts per centimeter square. Check this out. Okay. Okay. After this, so I finish with the first value of intensity of the beam in watts per centimeter square. The next thing asked is what? The sound pressure amplitude. Okay. Now to get the sound pressure amplitude I want, what is the formula? I need to know the value of P plus or P. Okay. So for this, what formula I'll use? I have been taught intensity formula I plus. The reason behind writing I plus or P plus is the acoustic wave traveling in the positive x direction. That's what we are assuming. Fine. So I plus, I taught the formula P plus square divided by 2 rho 0 C. Correct? So to know this P plus, I can use this formula because this value I know it. Done? So now what will I say? Therefore, in getting the value, I'll say P plus square is equal to 2 rho 0 C into I plus. Fine. Now how much is rho 0 C? We have been using the word water. The water rho 0 C value is 1480000 approximately. This value we are using into I plus. Now what is I plus? Is this value. So how much I'll say? It is 0.07961. One thing we have to be very careful now. In getting the sound pressure amplitude, obviously the unit will be Newton per meter square. Instead of making dyne per centimeter square, we'll make it Newton per meter square. But for that, this answer is okay, but we need to find out one more answer, even though it's not asked here, okay, but convert that in meter square also. So if I do that, what is the formula I'll have to use? I'll have to use the formula I is equal to 100. Okay, what I'm saying, I'll have to use the formula I is equal to 100 divided by 3.14 into 0.2 square. 0.2 is the radius. Fine. So this will give me how much? 796.1 watts per meter square. So this answer is absolutely correct. But to get the pressure in Newton per meter square, this is P plus square, but I need to know P plus finally. That's what I told you here. So to get this properly, I'll have to change this value to 796.1. Fine. So if at all I write this value, what is the answer I'm going to get? I will be getting P plus square to be 2, 3, 5, 6, 1, 6, 4 times 0. Verify this. Okay. So therefore P plus should be under root of this, and that comes out to be 48540.2 Newton per meter square. This is the answer for pressure. This is the answer for intensity. I can write I plus also, and this is the I plus in watts per meter square. So not difficult. Centimeter square, meter square, you need to know it. So this is the second question I have solved. Now the third thing. What is the third thing they are saying? The acoustic particle velocity amplitude. Now to get this, what I need the value of U plus. Now what is the formula for U plus? I will write. Third thing will be, I taught you one more conversion, which is I plus. I need U plus now. I plus I taught you is P plus U plus by 2. Correct? So there is one more formula I can use. Check answer with both the formulas, which is U is equal to P by rho 0 C. Fine. So if I use this formula, what I need to know, I know this. I know this. I just don't know this. So what will I say? U plus is equal to twice I plus divided by P plus. Correct? So how much is the value for I plus? I plus I got the value to be 0. I'll use this value now. Because I need the value also in meters per second of U plus. Okay, so I'll use this value. So 796.1 divided by P plus is how much? 48540.2. So if you simplify this, you are going to get the answer 0.03279 meters per second. Be ready with the unit. If there is no unit, your marks will be cut. Okay. Now here also, what is P? P is the value what I got now, 48540 divided by rho 0 C. How much is rho 0 C for water? 1480, 3 times 0. If you put this value, even then we should be getting the same answer. Try on your own. Correct? You know P plus. I need to know U plus. So U plus is P plus by rho 0 C. Rho 0 C for water, value is over here. Okay. So this answer should match. So 0.03279 meters per second is my third answer. So I finished with second and third. Now my next challenge is to get the acoustic particle displacement amplitude. Now to get this displacement amplitude, what formula I will use? I will use the formula which I taught during derivation of intensity and all. Okay. The formula I taught is I plus is equal to rho 0 C into omega square A square by 2. Fine. Now out of this, I know this. So it's not difficult to get me A square. So I can say A square is equal to 2I plus divided by rho 0 C into omega square. Okay. Now as far as omega square is concerned, we can separately write omega is 2 pi f. How much is frequency given to you? Calculate that separately. So f is, I think, 24 kilohertz. Okay, that is the frequency given to you. So 24 10 to the power 3, correct? So simplify this, you will be ready with your omega. Put that value over here. Fine. So my job is what now? Twice I plus. Now how much is the I plus? 796.1 in watts per meter square. How much is rho 0 C? 1480, 3 times 0 into this factor. Okay, so this is 2 pi f square. Okay, so if you simplify that, okay, I'll write the value here, you will verify the answer on your own. I'll just write down the, don't forget the square. Okay, so a square turned out to be 4.73 into 10 to the power minus 14. Fine. So then a will be 2.17 10 to the power minus 7 meters. This is my next answer, which is acoustic particle displacement amplitude. Fine. Now next job is asked is find out the value of effective or RMS pressure. Okay. Now to get the fifth thing, I have finished with first, second, third, and this was my fourth thing. Okay. Now to get the fifth thing, that is PE, effective pressure, is what is the formula? P plus by root 2. Fine. So how much P plus I got? I got 48540 divided by root 2 is 1.414. Okay. So if you simplify that, you will be getting the answer as 3432.96 Newton per meter square. Fine. Or I can write 3.4322 into 10 to the power 4 Newton per meter square. Correct. So I finish with the effective or RMS pressure, and the last challenge is sound pressure level SPL RE 1 microbar, which means denominator you will write 1 microbar. Okay. So to get the sixth thing, what formula I will be using? I will be using SPL. I taught you the formula, 20 log to the base 10 PE by P0. This P0 is reference value. Fine. So 20 log to the base 10, 3.4322 10 to the power 4 divided by 0.1. Why? Because 1 microbar, what is said? 1 microbar. So 1 microbar is nothing but, be clear in your head, that 1 microbar is 0.1 Newton per meter square. This I discussed earlier also. Okay? So this is 0.1 Newton per meter square. This is Newton per meter square. No problem. So if I simplify this, I will get the answer log of 3.4322 into 10 to the power 4. This is 0.1. 10 to the power minus 10 to the power minus 1 will become adjusted over here, and you will get the value 5.53, the log of this term. Okay, so the answer should be 110.71 dB. So this is my SPL, that or the sound pressure level answer ray reference 1 microbar. So this is the way we will be solving all the questions. So important point is, be careful that given is water, and if you use the value for air, everything will go wrong and there are no marks for the wrong substitution. If this is given centimeter, be careful. you need to convert later in the meter and get the value properly, that is a different idea altogether. But you need to be first clear as far as what is asked and what you are solving. Okay, correct? So this is the first question. Now question number 2 is concerned. A plane sound wave in air of 100 Hertz frequency has a peak acoustic pressure amplitude of 2 Newton per meter square. Calculate first one, intensity and intensity level, correct? Second one, peak particle displacement amplitude. Third is peak particle velocity amplitude. Fourth is effective pressure or RMS pressure. And fifth is SPL reference 0.0002 microbar. Done? So we'll solve this question now in a systematic way. So first what I need intensity and then intensity level. Correct? So the first part now is intensity. So what is the formula I'll use? I'll use I is equal to the same formula what I use. I'll say I plus is equal to P plus square divided by 2 rho 0 C. Don't get confused in why I am writing plus here. In theory we did not write, not an issue, because I told you the reason behind that. Fine. So how much is P given to you? First is underline the word air and pressure is 2 Newton per meter square. So substitute the value 2 bracket square divided by 2 into, this is air, so rho 0 C has to be 415. What is rho 0 C? It is specific acoustic impedance or characteristic impedance. Okay. So if you simplify this, you will be getting the answer as 4.819 10 to the power minus 3 watts per meter square. Fine. Because the unit for this should be Newton per meter square is pressure. Okay. And this also I told you, this is Raleigh's. So we have got these values 4.819 10 to the power minus 3 watts per meter square. So we have finished with the intensity. Now I'll move further with the intensity level. So intensity level formula is what? Intensity level is 10 log to the base 10 I by I0. Fine. Now how much is my I? I is this answer, 4.819 into 10 to the power minus 3 divided by I0. Now I0 I told you already, reference value is always this. Okay? So if you simplify this, correct, you will be getting the answer to be 10 into, this goes up, becomes plus. So we have the, we need to check the log of 4.819 10 to the power 9, correct? So the log of that should be 9.6829. So answer should be 96.82 dB. This is my intensity level and the unit I taught you is dB in the last lecture. Decibel scales and all. Fine. So first thing we have finished, which is intensity and intensity level. Okay. Now my next job is what? I need to find out the value of peak particle displacement amplitude. So second part. So to get this peak particle displacement amplitude, again the same formula I will try and use. Which one? I plus is equal to rho 0 C omega square A square by 2. Fine. Now I need to know A square. So what will I say? A square is 2I plus divided by rho 0 C into omega square. Now in this case, like last time, find out omega separately. Omega is 2 pi f. So 2 into 3.14 into frequency given is how much? 100 Hertz. Okay. So but you have to be careful as far as this square is concerned. So what will I say? 2 into I plus. How much is I plus? 4 point I plus, not IL. Okay. So I plus is 4.8 0.819 10 to the power minus 3 divided by rho 0 C for air is 415 into 2 into 3.14 into 100, okay, and that to square, so around 628 square. So if you find out the value, get the answer is around 5.8887 10 to the power minus 11. Then obviously get A. That should be your answer for what is called as peak particle displacement amplitude. Okay, find out, let me know the answer. A small job is given to you to do it. Next one. Next is question, I finished with 2. Now we'll go to 3. Now what is the third thing said? Is peak particle velocity amplitude. Now to like last time I told you the formula, I plus is equal to P plus U plus divided by 2, or U plus will be 2I plus divided by P plus. Fine. So if at all I want to use this formula, what will I say? I plus is how much? 4.819 10 to the power minus 3 divided by P plus is 2, because pressure is 2. Okay, so if you simplify this, you will get the value 4.819 10 to the power minus 3 meters per second. One thing is very important, that if this is wrong, this will be wrong, this will be wrong, this will be wrong, and so on and so forth. So that's the reason you need to be very, very cautious in doing the calculations. Now the fourth part. Fourth part is effective pressure or RMS pressure. Now what is the formula to get the effective pressure or RMS pressure? The formula is PE or PRMS is what the formula? P by or P plus by root 2. Now how much is P plus value I got? P value is given to you, so it's 2. So 2 by root 2. Fine. So this is how much? This is as good as root 2 into root 2 by root 2. So gets cancelled. So root 2, or we can say 1.414 Newton per meter square. So answer. So this is my next answer. Fine. So this is the way I finished with the fourth one. I'll go to the fifth one now. What is the fifth problem? Fifth problem is SPL RE 0.002 microbar. Okay, the last thing. Now to get this, the formula is what? SPL is 20 log to the base 10 PE by P0. PE I know, P0 is given. So 20 log to the base 10 1.414 divided by 0.0002. Correct? That is the value as far as microbar is concerned. Okay, that's what I told you. Next, so if you simplify this, the answer you will get is exactly 76 1.414 divided by 0.0002 should be around 76.98 dB. Okay, just verify this answer also. So this is the way you will be getting the problems solved. Okay, now the next one. What is the next problem now? The next problem asked is to get question number 3. Determine the energy density and effective pressure of a plane wave in air of 70 dB intensity level. Okay, interesting problem. So in this case, this is question number 3. First you need to find out energy density. Okay, now to know the energy density, you need to know obviously the intensity, because intensity level is given to you. Okay, so first we'll write the formula for intensity level, because that is given to you. is 70 dB intensity level. So I'll say IL is 10 log to the base 10 I by I0. Okay. Now I have been given IL, so I'll write here 70 dB is equal to 10 log to the base 10. I do not know I know I0. Reference value I always know. You can mention here I0 is 10 to the power minus 12 watts per meter square is given to you. Fine. So we can say 70 by 10 is log to the base 10 I 10 to the power minus 12. Okay. So means what? I need to know I. So what I can say, anti-log of 7, correct, is equal to I upon 10 to the power minus 12. What does this implies? This implies I is equal to 10 to the power minus 12 into antilog of 7, which is 10 to the power 7. So gives me 10 to the power minus 5, correct, watts per meter square. So I am ready with my intensity from the intensity level. Fine. Okay. Now the next job is what? After getting this, I need to know the value. Okay, with this itself I can get the energy density, so I'll get that first. So the energy density के लिए formula what I taught you, I is equal to C into E plus energy density. Fine. So I need to know this energy density term, so I can say I by C. How much I got just now? 10 to the power minus 5 divided by 343, okay, which comes out to be 2.9 into 10 to the power minus 8, okay, joules per meter cube, because this is energy density. So this is my first answer. Fine. 2.9 10 to the power minus 8 is the energy density. So I finished with the first part. Now I need to know effective pressure. Now to get the effective pressure, first I need to know the pressure. Okay. How will I get the pressure value? To get the pressure value, I need to know the I know I. So I can say as I is equal to P square by 2 rho 0 C. This I know. So I can say P square is equal to I into 2 rho 0 C. How much is I? I is 10 to the power minus 5. How much is rho 0 C? This is, first underline the word air or water. So if it is air, it is 415. Fine. So write the value 415. So how much you will get the value of P square? Check it out. Okay. After getting P square, which is around 830 into 10 to the power minus 5. Okay. Then to get the P, it will be around 0.911 Newton per meter square. So I got the pressure. Okay. Now after getting the pressure, what is my next job? Divide the pressure by root 2. You will get the effective pressure. So I'll write it here itself and say P by root 2, which is 0.0911 divided by 1.414 will give you 0.0644 Newton per meter square. This is my effective pressure answer. So I found out both effective pressure and energy density of a plane wave in air of 70 dB intensity level. Correct? So this is what my third question is all about. Okay. Now with this problem we have done completely with module 1. Now in module 1 syllabus, if you see, there is only one small topic, LL, loudness level, which will take it in the later module, because now there is no connection of taking it, so I will not take it now. Rest all, every topic is covered as far as module 1 is concerned. Today is 1st of October, so I am glad that I finished early. So end of this month we'll finish module 2 and the test also. Okay, so keep studying. Any difficulty, feel free to ask. Thank you very much.